Hi everyone. So for today, basically, I will be discussing on the chapter number 1, digital image processing, with the title Introduction to Image Processing. Okay, right. So at first, basically, we would like to describe or define what is the computer vision in context of the in general, and later on we will talk about what is the computer vision in the scientific terms or application. So right, the computer vision is interdisciplinary scientific field that deal with how computers can gain high level understanding from digital images or video. So in the general perspective, basically the computer vision is interdisciplinary scientific field, so whereby it is mixture of many discipline scientific field in order to get one direction of what we call it computer vision right now. So therefore here this particular field is deal how to computers can gain the high level understanding, so whereby this combination of the subfield will be combined together in order to give the high level of understanding for these particular computers. So by putting in the IMG, and it could be like a video, okay, so as the input source to the machine. Okay, so speaking of which, in the recent year we could listen, or we could heard about the what they call it IR 4.0 and so on and so forth. So in the industrial evolution, the fourth generation of industrial revolution is basically utilizing every single inch of the AI capability. So that's the reason why we lately we heard about the robotic, we heard about the autonomous car vehicle and so on and so forth. So artificial intelligence is basically the huge domain of making the machine artificially looks like intelligent compared to the human intelligence. Okay, so that would be the idea of artificial intelligence. They call it AI. Okay, so the computer vision, a field of artificial intelligence. So meaning, so this is AI. So this is computer vision inside the AI that train computers to interpret and understand the visual world. Okay, so this subfield basically trains the computer. What is the definition of train, guys? So meaning training is in a human activities, basically in order to get to have 100 meter less than 8 seconds, like Usain Bolt. So basically we need to have a good training mechanism, scheme, and timetable, right? So same as the human, same as the computer itself, it would be required to do a train in order to visualize the world by gaining the image, video, etc. Okay, so train me in this particular computer context. So we shall give 1,000 of images to fed in the computer, so that at the end of the day, the computer will be understanding what is this, and what is A, what is B for category, or for example, what is cat, what is dog, for two class of classification, right? So to do the vision, computer use the digital images which gain from cameras. So this will be the input device, guys, and videos camera, and deep learning model. So deep learning model is basically gain by happen from 1,000 or 10,000 times of training activities, and we have the models, okay, and machine. So obviously we have machine is depends on whereby we might be using the computer itself, desktop, workstation, we have laptop, we have tablet, we have Raspberry Pi, Jetson Nano, and so on and so forth. Okay, and at the end of the day, the objective is the same. Accurately identify the identify and classify the object accurately. Okay, so that would be the computer vision in the whole idea of layman terms, and this would be the specific terms. So we can take a look over here. Human vision compared to this computer vision to human vision. So hold on, I changed to the blue one. Okay, so we might compare it as humans see an object using the eyes, and the object is reflected to this retina, and this nerve or information will be sent to the brain. So, and then the brain will be digesting and will be classifying and telling to us what is this. Is it this could be bowl, and this could be orange, banana and apple and cherry and so on, right? So that would be the idea of things. So the computer vision is imitating the human vision system as a computer vision system. So this one is the brain, and this one is the eye or retina. This one is object will be the same. And yeah, at the end of the day, after gaining the models, so the brain could tell us as a bowl, oranges, banana, lemons, and peaches, right? So that would be the definition, right? So we will take a look at the evolution of computer vision since from the 1957. Oh, our Independence Day of Malaysia. So the first computer scanner copies 2 inch of photos. So just imagine 2 inch, about 5 cm. Okay, it's very tiny. Okay, succeed at okay, approximate 60 to 70 years back. Okay, and it followed by 1964, Woody Bledsoe, Helen Chan Wolf, and Charles Bison. Okay, facial recognition, the first unnamed. Basically they invented the facial recognition. So guys, take a look, 64. So 7 years after the independence. So people are, yeah, exposing or try to get as far as possible. So and then 8 years later, UK police invent license plate recognition. So whereby this will be the license plate recognition system using obviously image processing. Noted that this will be using the ring of steel. So right, 1985 is the first autonomous land vehicle, so suggested by the Lockheed Martin. 2004 Mars rover Spirit and Opportunity land, using the computer vision to calculate the distance positioning. Okay, so we might see in this evolution from the tiny this is small range of application going to big and less and more priority, right? So 3D profile for that started from 2008. And Kinect. Okay, Kinect is the kind of a depth sensor, guys. So we might call them camera. Okay, in the basic idea, we have RGB, camera, LiDAR, and depth. Depth is basically the way that, okay, example, this is the image, this is the people. So the color that specifying the foreground as black, and this is lighter gray kind of. So the lighter gray meant to be like the background is far, while the darker gray or blackish color indicates that the foreground is nearer to the sensor. So that would be depth. Okay. So also we do have thermal and etc. RGB is common. RGB, combination of 3 domain color. And we do have LiDAR. LiDAR is located at the automated driving autonomous vehicle ADAS. So happen to be in the latest MyV, if I'm not mistaken, and the coming S90 by Proton and BMW and Mercedes-Benz. Okay, 2014 phone processors become fast enough. So yeah, this is the evolution started from 2010 and 2023. So the improvement of Texas, what they call it, Apple I, later on, the latest one is A17, right? So Snapdragon Gen 2. Okay, so Snapdragon 8 Gen 2. So that would be the things happen, the evolution of cell phone chips. Okay, we can take a look at here, evolution of computer vision. We would divide it into two: imaging devices and computer vision. So we shall take a look at here. This one is OCR. This one is CMOS, guys. CCD. I think CCD is the sensors embedded in the back of camera as our retina. Biofilter camera. Nomad robot. So we have Kinect. Just now we did discuss about that, and BWI bots. Okay. So computer vision concept. So concept meaning how the people are trying to deliver a concept to make things easier in the people daily life. Okay. So stereo. See. So this one is SLAM. SLAM is particularly for the robot. Meaning localizing every each of the movement for mapping certain area. Shift is one of the feature for image pixel. So we have shift, we have ORB, we have SO. I forgot, back offwards. Okay, there you go. Back offward is around the corner. Okay, right. So because they are close enough as a feature. Active stereo is basic, particularly the people started to see the world by using several camera. It's not from only the mono camera. So real-time face recognition happened in 2004, and yeah, deep neural network, and we can see mass CRN, mass RCNN in 2016, right? Okay, so computer vision in multi-disciplinary field. So we can divide it into six huge category: biology, psychology, computer science, maths, engineering, and physics. So on top of that, basically we have the several multidisciplinary, as example, neuroscience, robotics, information retrieval, graphical, cognitive science, and so on. Right? Okay, these are the application for computer vision. We might be seeing very huge of application happen. Let's say we take as the example of agricultural. So farming activities monitoring. So that could be IoT stuff. Crop well-being and quality detection. So this would be the farming in order to gain the high quality of output for agriculture. Soil and crop condition. So sensoring or investigate the soil and crop condition under the land. So aerial imagery is for the drone, right? So we might see very huge and vast application happen in computer vision lately, starting from 2010. So that would be just for agriculture. So we might take a look at the automotive, obviously autonomous, sports, manufacturing, and surveillance. So the one that I discussed in class is the example of the JDT team has the how to say, data statistical stuff from Argentina, the female doctorate stuff by JDT. So I think we did discuss earlier in the class. Okay, so speaking of the intersect or the how the domain is defined. So the biggest one is artificial intelligence, obviously AI, and followed by ML. Okay, so and again, this is computer vision is basically on and off. Also because the computer vision could be directly for AI, and sometimes computer vision is directly for machine learning without going to purposely for AI itself. Okay. So while the robotic and sensor, so robotic obviously we do have another application that we call it robot vision, guys. Okay. So biometrical is mainly regards to humans, animals, and so on. Okay, this is the one that the domain or Venn diagram in order to portray where is the artificial intelligence, where is the machine learning and the deep learning. So the parents domain for all the three is AI, followed by the smaller one is machine learning, and the tiny one is a deep learning. Okay, so meaning deep learning is a part of machine learning, and the machine learning is a part of artificial intelligence. So while the father or the mother main domain is AI itself. Okay, so this would be the evolution of AI. So starting from 1950 to 80s, so AI started. So followed by machine learning become details. Okay. And this, it could be like a feature strategy. Okay. So deep learning is, we can call it black box. So we put in and we get output. So that would be the happening after towards 2010. Okay. Okay, so this is the way that the machine learning and deep learning in computer vision are represented by using the search illustration 8. So imagine that this would be the input side of a system. So this would be the output side of the system. So the difference between those two is this, guys. So whereby, as I mentioned earlier, the deep learning is such a black box, things like that, while the machine learning is studying or analyzing the feature at first, extraction, before they're doing the classification task. So that would be ML. So compared to DL, so DL is straightforward, put in and get out. I mean, the output is out from the training or classification activities, right? Okay, so apart from that, there will be many things to be considered as computer vision using deep learning technique. So, right. If you take a look here, we have two boys and one car at the back of the scene, and we have field and we have the what's so called, this is ground. Okay, so a car is behind, so meaning the car is one domain. So the explanation of the car itself is located at behind of the boy. So that will be going through this way. Okay, so then speaking of the boy, what is the boy is doing? So is it playing tennis, wearing shoes, shirts, and so on, holding what? And what is the location of the boy? Is it the blue, wearing the blue sweater boy is on the right hand side, while the red, wearing the red sweater boy is on the left hand side. So things like that. Okay, so that would be the subcategories and so on and so forth in order to retrieve the images by using the scenes of the graph. So that would be happening in 2015. Okay, right. So not to forget about the challenges happen in computer vision, dedicatedly in either deep learning or machine learning. So obviously viewpoint variation. So this is the same idea, it's the same object, guys. So viewpoint variation is basically the way that the camera is exposed to the object, either from what kind of angle. So that's what we call it viewpoint. So meaning it could be difficult to trace the full face of this object from this angle, but if using this angle and this is a kind of top angle, so that would be easier to see the full face and nose and chin and so on. Okay, illumination condition is whereby if you take a look at this and this, it obviously different. So just imagine these two and these two. So that would be the impact of illumination. So this will be the struggle within of those who are competing in computer vision and doing the research. Okay, scale variation, obviously, the scale either human and human. So this will be the scale. So just take a look at the computer itself too. So this is small, this is big. So it is the same object and the same things, but that would be the different view from the computer vision because of the scale. So in terms of the coefficient that has been multiplied for those object. Deformation is example. This is a cat. So the cat is obviously head, body, and 4 legs and 1 tail. So that would be the formation of a normal cats, right? So, but here we do have a kind of different formation of the cat. So that would be the struggle, and to make computers understand about the formation of one object. Occlusion is occluded, whereby the cat is not seen for the full body of the cat. So while the head are exactly seen and included by the table somehow. So clutter background meaning the same, the foreground and the background is the same, clutter. Intra-class variation is whereby we talk about the same object with the variation of types. Example, chairs. We do have a class chair, we do have office chair, we do have pub chair, we have kitchen chair, we have double chair, and so on and so forth. Right? Okay, challenges. We could see the scenario when we talk about outdoor scenario. So when we talk about outdoor, comparing to the indoor, uncontrolled condition, so unexpected situation, obviously, and whereby the hypothesis happen in indoor scenario, it may not be satisfied in the outdoor scenario. So that would be things to be noted. So the higher scenario variability and the higher complexity of the algorithm. So meaning if we do the computer vision of several angle of variation, viewpoint, illumination, scale, so the more variation that we have, the more complex algorithm. So likewise, if, so the more that we go to the deeper programming codes, so the more computational power required. So whereby loop is more and time is more, whereby power is more, right? So that would be the things. So the second is the embedding computer vision algorithm. So how we embed those things that we try to propose in the real time. So how to specify the spec of the images in hardware environment, optimize the algorithm in software environment. So later on, after we embedded in hardware and software, so how about the testing period? So the processor is enough to handle every single thing in train and test environment and so on, right? So not to forget about the CUDA and the way that the code itself required to the calibration and maintenance beforehand to put in the real situation, right? Okay, right. So that's all for the first part of chapter number 1. So we will talk about the second parts of chapter number 1 in the next video. Okay, I think that's all. Bye. See you in the next video. Okay, thank you guys for watching NMZH channel. Hopefully you can get knowledge and benefit from the videos. Thank you so much. Assalamualaikum.